I'd like you to start with these warm-up problems. Press pause on your video, do the warm-up problems, and when you're ready, press play to see the answers. Here are the answers. Hopefully you got them correct. If not, take a look at the work and see where you went wrong. Today we're going to talk about some more strategies for solving logarithmic equations. Here is one strategy. You're going to combine logarithms on each side of the equation. So you'll notice I have two logs added together equal to another log. Well, I know that the sum of the logs is the log of the product, so I combine these two into one. Then at that point, because I know I have equal logs on both sides, the arguments must be equal. So I know that x times the quantity x minus 3 has to be 4. Multiply this out and subtract 4 from each side, so you're setting it equal to 0. Factor, and then set each of the factors equal to 0. Then the next thing that is really important is that you check to make sure that each of the solutions work. When we're solving logarithmic equations, it's possible to get extraneous solutions. So if you plug in -1 here, you'll notice you have log of a negative number, and that can never ever happen. So -1 is eliminated. So we're going to solve this logarithmic equation next together. You'll notice I have the sum of the logs on the right hand side. I'm going to combine those so that I have the log of a product. Now I have two logs with equal bases set equal, so I know that their arguments have to be equal. So x plus 8 has to equal x times the quantity x plus 3. We'll distribute the x so that I have x squared plus 3x equals x plus 8. We'll set this equal to 0. So that gives me 0 equals x squared plus 2x, subtract x from both sides, subtract 8 from both sides. Now I've got to think of two numbers that multiply to -8 but add to +2. So x in both of these spots, what multiplies to -8 but adds to +2 is +4 and -2. We'll set each of the factors equal to 0, and that gives us x equals -4 or x equals +2. We've got to go back and check these answers in our original equation to make sure it works. If I put -4 in here, that will not work. It gives me an extraneous solution because I cannot have a negative value inside a log. Same thing over here, that's a problem. So the only solution is x equals 2. Another strategy for solving logarithmic equations. The last one that we did, we had logs on both sides of our equation. In this one, that's not the case. So I have the difference of logs on the left-hand side and just a number on the right-hand side. So I'm going to combine the logs so I have log of the quotient, because this was a difference, equal to a number. Now, exponential and logarithmic functions undo each other. They are inverses of each other. So I'm going to raise each of these as exponents with a base of 10. So when I have that happen, the 10 and the log undo each other. So I'll have x plus 2 over x equals, why does that say 5 squared? Oh, I know why. Let's go back. Let's go back here. Somehow along the way, I lost the base 5 here. Let's try again. So we're going to raise each of these as exponents with base 5. These cancel, and I end up with x plus 2 over x equals 5 squared. Then at that point, I need to solve for x. I multiply both sides by x, and then isolate x, and I get x equals 1/12. It's still important to check, does this answer make sense? And it does. I do not get a log of a negative, so I'm absolutely fine. There's one solution. So now we're going to solve this one. Notice I have the difference of logs is equal to a number. So this is log base 3 of 9x over x minus 8. That has to be equal to 4. So I am going to raise these as exponents with my base being 3. So that would be, these would undo each other. So I have 9x over x minus 8 is equal to 3 to the 4th, or 81. Multiply both sides by x minus 8. Let's see if I can do this in my head. 8, there we go, 64, 648. Now, subtract 9x from both sides. That would give me 72x. Add 648 to both sides. 72x equals 648. Divide both sides by 72. And that is 9. Double check that this makes sense.
I get my variety of total.
9 would make this a positive in here. Same thing here. We're all good. Okay, and we can double check if we actually plugged in. I'd get log base 3 of 81 minus log base 3 of 1. Well, log base 3 of 81 is 4. Log base 3 of 1 is 0. And sure enough, those are equal. Now I'm going to solve a different kind of logarithmic equation. We're going to keep remembering we have to undo what's there. The first thing I want to undo is this ln. ln is log base e, so I'm going to take each side as my exponent on a base of e. So these undo each other, and I'm left with log base 10 of x is equal to 1. Again, now I have to undo the log. So each side becomes an exponent on the base of 10. That gives me x equals 10. And again, you should always double check that it works. And of course it does. Let's just do it. ln of log base 10 of 10. Log base 10 of 10 is 1. ln of 1 is 0. Now we're going to solve this one. Now you'll notice I have 5 to a power, but it's not 5 to the log base 5 of something. That would be really nice. This is 2 plus log base 5 of x. So I've got to separate this. So let's write this as 5 squared times 5 to the log base 5 of x is equal to x cubed. Notice, when I multiply, I add exponents. That's why I'm able to do this. This becomes 25, and this part cancels. So I have 25x equals x cubed. Now, we'll subtract 25x from both sides. Notice I am not dividing by a variable.
Oh, wait, we were looking at
Factor out an x. The proper procedure is always to set it equal to 0 and factor. So now I have 0 equals x. I'm going to factor this again. So x equals 0, 5, or negative 5. Again, we have to check that all of this makes sense. Look up here. Now, if I plug negative 5 in for my log, I'm going to have a problem. There is not an exponent that will make 5 to any power be negative 5. So this is not part of my solution. If I put 0 in here, there is no power of 5 that's 0. So that is not a solution. The only answer is 5. And let's just take a look at that. That would be 5 to the 2 plus log of 1. 2 plus
I'm just going to talk about
log base 5 of 5. And the question is that equal to 5 cubed? Well, let's see. 2 plus log base 5 of 5. Log base 5 of 5 is 1. And sure enough, it works. So there is one solution to this equation. Remember, you always have to check for extraneous solutions. Now, I want you to take a few minutes and I want you to solve these problems. Press pause on the video, and when you're ready for the answers, press play again. Here are the solutions. Take a minute, check your work. If you got the wrong answer, go back and check my work to see where you went wrong. Now, I want to give you one other kind of problem. Let's see. 3 to the 2x minus 4 equals 5 to the x plus 1. Now, to undo an exponential equation, I want to take the log of both sides, but the problem becomes, which base log do I take? I have a base of 3 on the left, and I have a base of 5 on the right. So, I've got to decide. I'm going to choose to take the natural log of both sides, but I would suggest that or the log base 10. Because when I do that, I can get my exponent, my variables out of my exponent, because my exponents are going to move to the front. So this becomes 2x minus 4 times ln of 3. That's equal to x plus 1 times ln of 5. Let's distribute the ln of 3 because it's just a number. It's not a pretty number, but it's a number. So that becomes 2x ln of 3 minus 4 ln of 3. That's equal to x times ln of 5 plus ln of 5. Now we're going to take all of our terms that have x's in them and move them to the left side, and all of our terms without x's in them and move them to the right side. So I'm going to subtract out x ln of 5 from the right, and I'm going to add 4 ln of 3 on the left. So I end up with 2x ln of 3 minus x ln of 5 is equal to ln of 5 plus 4 ln of 3. Again, my goal is to solve for x. So at this point, I'm going to factor in x out. Now, I have x times a number. It's an ugly number, but it's still a number. We'll divide both sides by 2 ln of 3 minus ln of 5. Don't like how that came out. Hold on.
Oh, right. I wrote down it's like the homework.
But then we're going to do
2 ln of 3 minus ln of 5. That is the exact answer. The approximate answer is something you get by putting in your calculator. And I want to actually pull up the calculator so I can show you. I'm doing this because it's important to get your parentheses in the right spot. So this would be parentheses, so you have that in your numerator, ln of 5 plus 4 ln of 3, and you need an end parentheses, and now you want to divide by this whole quantity in the denominator, so there's a parenthesis there, 2 ln of 3 minus ln of 5, and then 2 parentheses here. So that is approximately 10.2. That is my approximate answer. 10.2. So when you have exponential functions, different bases on each side, take the natural log of both sides to get the exponent, to get your variables out of your exponent and solve for x. The next thing I want you to do is check on Schoology for your assignment and work on that. Have a nice day and a nice weekend.
It's so weird.